All right, today we're going to be talking about factors and multiples. Now these are one term that we've kind of used before, but we're going to use it in a slightly different way, even though it really means the same thing. And multiples is a new term for us. So we're still trying to answer or look at how multiplication and division are related. Now before we go into the math problem, I want to look at factors again. Factors are two or more numbers that are multiplied together. So if we were to look at 4 times 2, I meant to do 3, that's going to equal 12. Now another way to look at it is numbers that can be multiplied together to get the same answer, and that's how we're using it today. So for example, 12 has the factors of 4 and 3, but it also has the factors of 6 and 2, because if I multiply 6 and 2 together, I get 12. Now we're going to start with that, and then we'll look at multiples in a few minutes. So let's start with this example here. Mrs. Navarro is arranging the desks in her classroom. There's 12 desks, and we're looking for how many different ways she can arrange the desks so that the number of desks in each row is the same. Now this is the key right here. The number of desks in each row is the same. The only way we can do that is by using different factors of the number 12. And that's why how the rows are going to have the same number of desks each time. So what we're going to do is break down the number 12 into factors. Now decompose, if you think about it, decompose with plants and animals is that it breaks down into smaller parts, and that's what happens when you leave like a piece of fruit out. It breaks down, it starts to get moldy. That's bread, or that fruit is being broken down into more basic components. Well, in this case, what we're doing is we're taking the number 12 and we're breaking it down into more basic components. So let me give you an example of that. This is one row of desks with 12 desks. So 12 desks in one row equals 12. Sorry, I did that backwards. One row of 12 desks equals 12. And so as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if we turned this sideways and just did 12 desks in one long column, or 12 rows, then that would be 12 rows of one desk. And I'm looking over here at this helpful hint. I'm going to do that for each one. So the next one we have here is 2 rows, 1, 2, 3, 4, 5, 6 desks equals a total of 12 desks. We could also do 6 rows of 2 desks to get the same answer of 12. Last one is we have got 3 rows, and there's 1, 2, 3, 4 desks in each row. So 3 times 4 equals 12. Or we could do the opposite of that and do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is now 4 rows of 3, which is this problem right here. So what we're looking at are the 6 different ways that she could arrange the desks, and the factors are all these numbers. So we're going to start with the lowest one, the 1, then we've got 2 and 3, 1, 2, 3, and we've got 4, no 5, we do have 6, and we have 12. So those are our factors. We could also just write these numbers down here. Now it's nice to write them in order, because there is going to be a time when you look for the smallest common factor or the largest common factors that 2 numbers have. So if you write them down from the smallest to the biggest, that will make it easier for you to do that. Now we could just count how many there are. There's 1, 2, 3, 4, 5, 6 different ways. or we could count them 1, 2, 3, and don't forget these are 3 ways, 4, 5, 6, to get 6 different ways the desks can be arranged. So that is factors. We're taking a number, we're breaking it down or decomposing it into smaller parts and coming up with what those different smaller parts are. Now we're going to take a look at multiples. So a multiple of a number is the product of that number and any whole number. So before we go on, a multiple of, say, 6. Well, we can do 6 times 1, 6 times 2, 6 times 3, and these are what we call whole numbers, meaning it's not part of a number. So I know you guys have had some introduction to fractions. This would be 1 out of 4. So this is a whole number. 1/4 of that number, or 0.25 of that number, is not a whole number. So we wouldn't do that. We would only do whole numbers like 1, 2, 3, and so on. And so it gives an example. 15 is a multiple of 5 because it is composed or made of 3 groups of 5. 15 is also a multiple of 3, and it would also be a multiple of 1 because 1 times 15 equals 15, and it's also a multiple, and also 15 is a multiple of 15 because 15 times 1 equals 15. So we can figure out the multiples of a number. What we have here is a multiplication table, and if you wanted to find out the different multiples for a number, you could just find that number on here. So we've got 1 and 2, and 2 and 1, and we honestly don't have any others because 2 only appears 2 times on there. Any number that appears, well, that doesn't always work because 100 has more than just one multiple. It has a few others, but we can use this multiplication table to give us an idea of multiples. So all of the numbers listed in row 7 or column 7 are multiples of 7. So we had 2. These are all multiples of 2. 2 times 2, 4, or 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, and so on. And in this case, they're giving the example of 7. So if we go to 7, 7 times 0 is 0. 7 times 1 is 7. 7 times 2 is 14. 3 is 21. And 28, and so on. So this gives us an idea of what numbers are multiples of a number. Now, if you look at 10, all of them end in a 0 because that's part of how 10 works. And these are all the multiples of 10 up to 100. Okay, so the first 5 multiples of 7 are 0, 7, 14, 21, and 28. 28 is a multiple of 7 because if we go across and look right here, 4 groups of 7. So 28 is a multiple of 7 because it is composed of 4 groups of 7. It's also, not that you can see it on here, a multiple, well, let's just leave it with that. All right, so now we've done this, let's go ahead and go on to some practice ones that we can do together. So we're going to find the factors. Now think about which one is the factors. Factors are decomposing. So up above we did the factors of 12, and we had, you could do 12 times 1, or you could do 3 times 4, and so on. So we're looking now at the factors of 6. Now I know that anytime we've got the number, we multiply any number by itself, we get 6. We multiply a number times 1, we get that same number. So that's why I would always start with putting the 1 first and that number next. Now, what are some other ways we can get 6? 6 is an even number, so one thing I know about even numbers, I can always divide them by 2 and get half of what they are. Now, that doesn't work with odd numbers, but we'll try one of those out later. In fact, we'll get a chance to do that at another time, but these are our factors. Now, I could also try, so I've tried 1, 2, 3, and 6. I could try doing 6 divided by 4. But if I do that, I know I'm not going to get a whole number. Same thing with 6 divided by 5. For 6 divided by 5, I'm also not going to get a number. That's going to be between 1 and 2. So that is not a factor of 6. Now let's try 36. Well, the first thing we're always going to do is write the 1 here and the 36 here. My next step is, what if I do 2? Well, 36 divided by 2, 2 times 3, or 2 times 1 is 2, so 3 minus 2 is 1. Bring down the 6. And I know that 2 goes into 16 8 times. So 36 divided by 2 is 8, and that's going to be the next biggest number on this side. Then I'm going to try 3. So 3 into 36. If I do 3 times 1, I get 3. So that brings that down to 0. And then so 6 divided by 3, well, if I do 2 there, I know I get a 6. 6 minus 6 is also 0. So 12 is the factor that goes along with 8. Let's try 4 now. 36 divided by 4. I happen to know the answer, but 4 does not go into 3, so I have to divide the whole 36 by it. So I know if I could do 4 9 times, I get 36. And that's what I know. If you don't necessarily know that, that is okay. So we've got 4 and 9. And we've got one more. 5 isn't going to work because 5 times 36. We get 5 times 7 is 35. So that's not a good factor because that'll leave us with 1, and then we're going to have a long decimal going there. So 5 is not. What about 6? 6 into 36. If you look at the multiplication of the skip counting on the wall, or the multiples of 36, or the factors of 36 on the wall, we've got 6. Or if we skip count, 6 is, I guess, is what I mean to say. We've got 6, 12, 18, 24, 30, 36. 1, 2, 3, 4, 5, 6. So 6 times 6 is 36. Now, I'm only going to write 6 once because you only want that factor up there once. The last number, because we already know 8 is, oops, why did I write a 9 there? That's a, oh, Mr. Johnson made a mistake. So that's an 18, 12. I did write 9. Oh, never mind. 9's supposed to be there. My apologies, guys, because that's 4 times 9. We're going to try 7 because this is our last possible factor. 36. 7 times 5 is 35, and so no, that doesn't work. And I'll teach you when you come and sit with me in a little bit. I'm going to show you how you can use the skip counting table on the wall for now to help you figure out the factors of a number. So I forgot commas over here on number 1. So here are our factors: 1, 2, 3, 4, 6, 9, 12, 18, and 36. Those are our factors for 36. And the way we know it is we divide it. Okay, let's go ahead now and identify the first 5 multiples. Well, what that means that we're going to do is we're going to multiply 4 in this case times 0, then times 1, 2, 3, and 4. I would like you to go ahead and do that on your own. And then again, when we come in together in group, I will show you a trick how you can use our skip counting chart on the wall to answer that question. All right, go ahead and pause the video. All right, so our multiples of 4 are going to be 4 times 0, which is 0, 4 times 1, which is 4, 4 times 2, which is 8, 4 times 3, 12, and 4 times 4 is 16. These are the first 5 multiples of 4. Now what I want you to do, go ahead and pause the video and try the same thing with 9. All right, let's do this. So the multiples, 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4, oops, I forgot one, 9 times 0 is 0. 9 times, I'm getting ahead of myself, 9 times 0 is 0, 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, and then 9 times 4 is 36. Now, one other thing I can show you that works for both of these, 0 plus 9 is 9, plus 9 more is 18, plus 9 more is 27, plus 9 more is 36. Worked over here too, 0 plus 4 is 4, 4 plus 4 is 8, 8 plus 4 is 12, 12 plus 4 is 16. So that's a way you can go back and double check your work and make sure that it makes sense. I'm going to go ahead and stop the video now. What I want you to do before you come up for group is I want you to do the odds on this independent practice page. Okay, and after you are done, I want you to raise your hand. If you get stuck, also raise your hand. If I'm available, I'll come and help you. Otherwise, Mr. R or Mrs. K will come and assist you and help you figure this out. All right, guys, good luck and thank you.